Great to have all of you in the session back. And so far we have discussed about HBase. We're going to um, cover a bit more about HBase. Then we'll start with Sqoop and Flume. Okay. Uzi we will do towards the end because that includes and also depends upon Spark. Okay. And I would recommend that you follow the steps by yourself in all of the hands-on. Okay. And there is a question from Robin that, by the way, when is the deadline to finish all the projects and deliver deliverables by Big Data with Hadoop for full course completion and certification? All right. So let me just check with the dates of Spark course that will be starting tomorrow, as in the second class is tomorrow, and then we'll let you know. Okay. So any other questions before we start? Is there a certificate for first part of the class? Good question. So um, we can give you the certificate for the first part, but it will be better to club both of them together and give you one certificate for both if you have signed up for Spark as well. And otherwise, if you have signed up only for Hadoop or only for a particular class, the Spark class, then you will get the certificate for that part. All right, great, great. And yes, I can see that most of you have completed the exercises in the self-paced one, and you should finish all of them, make them 100%. And also, so basically that is that it has quizzes, and some of it are the exercises with respect to the hands-on. So you should complete those. All right, great. All right, so any other questions related to the HBase? So Robin's question is, can I have one certificate for Hadoop and one certificate for Spark? Yes, you can have. Okay, you can definitely have. And yeah. All right, great, great. A question from Godwin is, can we extend the lab sessions for some extra time? So yes, we can do that. Also, you can share the lab with, as in you can refer a friend and it will automatically extend for 15 days. And yeah, so that is another thing. So you can just share the lab and refer a friend. So otherwise you can just extend. All right. So for duration of the classes, whatever are the classes until the project is done, the lab will be enabled for you. Okay. And beyond that time, okay. A question from Alok is that I have some questions. Sure. I would, yeah, we can have some discussion after the class today. No, but I can have 5 minutes discussion or some discussion during the week. After the class today, it becomes really hard for me, and because I have a hard stop at 11, so it's very important for me to um, stop because I have another session in the morning. So it becomes difficult. Question from David is Tableau needed for other project other than Hive, as license is good for only 2 weeks? Not much. So Tableau is actually generally a useful tool. Okay, Tableau is generally a useful tool, and the license is okay. So license is only for 2 weeks. Okay. So I think this project, we are not using the Tableau for other projects. Okay. So that should be good enough, the 2 weeks license. Okay. Any other questions before we start? So last time we discussed about the data model. I hope everybody is clear about the data model of HBase. Okay, can you please share the slides of HBase? Okay, sure, I'll do that. And okay, so sure. So let me just share with you. Just give me a second. Sure, sure. I'll just share the link with everyone, so no worries. Okay. All right. So this is the link for the PDF. Okay. So before the other question to all of you is that do you have any doubts related to the data model of HBase? No questions? All right. So far what we have learned. So the classes that you can skip again is the programming of MapReduce programming that we discussed earlier, and the Java classes. Okay, those are the chapters you can skip again. Okay, so yeah. All right, all right. So good that we are asking that question. All right. So question from Grisma is that is it mandatory to know Java for MapReduce? I mean, from interview perspective, not really. So you can always tell that, let's say in an interview, somebody asked that, do you know MapReduce programming? Okay, do you know MapReduce programming? Then you can tell that, yes, I understand the concept and I can do it using Python or Shell or any other programming. And I'm not too good with Java right now, but I can learn if needed to. Okay. So, I mean, if somebody asks me the same question that let's say I don't know Java. Okay. I don't know Java, and somebody asks that, hey, can you do you know MapReduce programming? I said, yes, I know MapReduce programming. And then the next question would be then, You don't know, but you don't know Java. So you can say that yes, the MapReduce programming can be done without Java, and you can do it using Python, Spark, Python, or Shell, or any other language, and that is done via MapReduce, something called Hadoop streaming. Okay, so that way you can always answer it. All right, good question. So I mean, the fact of the matter is that even though I know Java, most of the real programming, real work on Hadoop I have done using Python. Okay, so the Java part was done at the end of the project. Once the first version was out, everything was running fine. Just to be uh, just to do something really nice, we decided to rewrite it in Java, but it was not really required. Okay, wonderful to have all of you in the session. So I mean, till the last time we learned about these parts. So we learned about that how did we handle humongous data in the form of tabular structure in HBase. This wasn't possible using HDFS because HDFS was not allowing us to create columns and rows. It was only giving us functionality of uploading files, creating folders. All right. So here what you have is, as we are adding content, so let me just go over the problem again. So the idea is that given the internet kind of data, the humongous data, in the form of web pages which are linking to each other, we want to maintain the relationship between all the pages that we are downloading. That's what the search engine does. Search engine downloads the data from across the internet and basically creates a relationship between the pages, and based on the relationship it gives the value to one page versus another. All right, that's what search engine does. The page ranking is done based on who is being linked the most and so on. Okay, and who is being linked by the most important pages. So that's how the web search engine works. So here what we demonstrated was there was a website called cnn.com which has content, and then there is a website called si.com which has some content, as well as it is linking to cnn.com. And then we have another website, microsoft.com, which is linking to both si sport illustrated as well as cnn.com. So as the search engine discovers cnn.com, it adds the row, or it adds a particular row key called cnn.com and the contents. And similarly, si.com, when it stumbles upon si.com, it adds a row here, and then it also parses this data. Once it parses this data, it discovers that this one is linking to cnn.com, and hence this one creates a column called si.com, okay, meaning that this si.com is linking to cnn.com with a value this. This is the text, the hyperlink text. So this website is referring to cnn.com with the name CNN. All right. Further, it stumbles upon Microsoft.com and figures out that it is basically Microsoft.com is linking to these websites. Okay. So again, it goes ahead and adds one more column. So you can see that as and when it is finding a website, it's adding a row and optionally a column. Okay, if it is linking to another website, and it's very common that it's going to link to some website at least, therefore it's going to add a column. So rows and columns are increasing together. So that was the sole idea. Then we further discussed that since the way, if we normally list the website this way, the data will be, row keys will be sorted, the data will be sorted based on the row key, and hence the same domain such as Microsoft, because of subdomains, it will be separated. If there are millions of rows in this one, the chances are the two subdomains of Microsoft.com are separated hugely. So let's say we want to find out all the subdomains or all the pages of Microsoft.com. Then we won't be able to scan through this one because they are far away. Okay. The data model of HBase allows you to scan from a particular key further. Therefore, these are separated ones. So that's the reason that if we just inverse the row key, then these subdomains will be together. Now, further question that occurs is what happens to, let's say, Microsoft.in, right? In those cases, either we maintain a separate alias table, okay, and we basically rename Microsoft.in to Microsoft.com and then follow this principle. Okay, so here when we have reversed the order of the domain, then all the subdomains of com.microsoft to Microsoft.com has come together. That means that we can just search for com.microsoft, and then from that point of onwards, we can just scan through the data. We don't have to again search for any other subdomain. All right. So therefore, searching for a particular domain becomes really easy by reversing the name. All right, because the data is ordered by the row key. All right. So we also did hands-on last time. I hope everybody was able to do the hands-on. Right. The next question that we have not yet answered is, where is the data for HBase, right? Where is the data for HBase? Now, whatever tables we create, the data is created in this folder, okay? The data is created in this folder. Let me just show you this. So if we go over here into Hue, all right. So Subbu's question is, can you post the hands-on script? I'll have to exit the presentation mode. And if you want, you can just take a look at it here. I'm copy pasting it. Here you go. All right. So you change the names of tables and change the name of the rows and columns as per your wish. All right. So great. So let's just go ahead and what was the name of the table that we created? Okay, so let me just open a console here. This console is good, not this console. The other console, the one that is in Jupyter, is good because I don't have to log in every time. So I'm just going to exit this. And instead, I will just open this console. I'm already there. I'll just refresh it. Okay. So here we are, and we were talking about HBase shell. What was the name of the table? I forgot. Let me just go over to HBase first. Now, let's go to the data browser and click on HBase. Okay, I'm just trying to locate that table name. What was the table name that we created last time? Okay. All right. Is this the one or SG17 March? Okay. Let's just take this case. All right, so we have a table called SG17 March. Okay, let me make a note of it. Let me save my previous notes. Okay, so you see that there is a table here. It has first row, second row. The first row has this key, second row has this key, and the first row has these two column families. The second row has one column family, and so on. Right? So this is the one. Now let's open the file browser parallelly. Okay. Now, if you take a look at this, the folder name that we were talking about is this. You go to apps, HBase data, apps, HBase data. So you go to the top level, apps, HBase data, and inside data there is again another data folder. Okay, this is the place where HBase keeps its data inside HBase. There is further staging and data inside data. Then you have the other folders. This is the one that keeps the database tables. Okay, this is the one that keeps the database table. All right. So here you can see that we have. Okay, what was the name of the table? The table name was, okay, this, all right, this is the table name. Table name is SG17 March 2018. SG17 March. So I'll just search for my table in this. Okay, so at this location, you see, there is a folder called data, inside HBase, inside apps. All right, so looks like the table that we created isn't here. Okay, I think we deleted it or something. Did we delete it? Okay, so we just saw that it exists. Yeah, it does exist here. Okay, so here you can see that the table is existing. All right, so yes, it is there. Now going back here, and I'm just wondering what happens here. Okay, so let me just open default. Yeah, so that's what is mentioned inside default, right? Apps, HBase, data default. So the HBase also offers something called namespace. By default, since we have not specified any namespace in our tables, everything is created inside default. Okay, and so here, if you just search for the folder SG17 March. Okay, so you can take a look. All right. So, so what we understood is that our table that is created in HBase is created in HDFS, right? So for every table that you create in HBase by using the syntax that we have discussed earlier, there is a folder that is created in HBase, in HDFS. okay, inside this location. Apps, HBase, data, default, and here. So this is where HBase is keeping the data for your tables. All right. Now here is an interesting part. Inside this place, inside this place, there is a table name, and inside this table there is a region. Okay, there is a region in which it is keeping. It is the region. Remember, the bunch of rows is called a region. So those bunch of rows made up the region, and inside the region we have this region is basically it has the ID automatically generated. Inside the region we have column family. We have column family. Right now we have only one column family called MyCF. Okay, inside the column family we have the actual data file. We have the actual data file. Okay, now here this clears multiple doubts. One, you'll notice that here as and when we are increasing data in the table, these folders will keep on increasing. As the data is in our table is increasing, this this folder will similar folder will start being created here. Remember the discussion where we had that the region splits when the data increases? That's what happens. Okay, so there'll be multiple such folders. Now inside each folder we have column family. Further, for each column family there's going to be separate folder, and hence the data inside a column family stays together in a same file. Okay, which means the data is saved for each column family. Data is saved generally in a single file, and hence the data, the columns that belong to the same column family are going to be stored together. So if we are accessing all of the data belonging to a particular column family, all of the data will be read from mostly the same file, and hence the access to the columns inside the same column family is going to be faster. All right. Okay. So Vidnav's question is, my SD folder is empty. Probably that there is a search filter here at the top that is causing the problem. Okay. So yeah, I think that would be the mostly the problem. All right. Remove the search filter from the top. Okay, because if you have, yeah. All right, so great. And inside this, so I hope that you got the idea that for each table, first of all, there is a folder for each namespace. Then there is a table inside there. For inside each table, there is a region. Inside every region, there is column family. If there are multiple column family, there will be multiple folders here. And inside the column family folder, we have the data. This data is stored in a proprietary format of HBase, okay? And this basically data blocks, it's a binary data, all right? Great. That's right, Noor. So every region means a group of columns, correct? That's right. Okay, so great. So we are able to now. So this is where our data is located. Now, there is another very important question that people ask in the interviews, and this is also one of my favorite questions. And yeah, this one actually it comes in many formats, outside even outside the big data world, and it comes in many formats. As in, given a problem, it'll basically you will have to figure out whether this particular data structure can be of help or not. Okay, so let me explain to you this one again, this one in detail, and then we'll talk about the various other applications. All right, so one of the ideas that HBase works upon is Bloom filter. Just like in the database tables, you have indexes. Similarly, we have here there is an additional concept called Bloom filter. When we are searching for something in really humongous data, when we are searching for something in really humongous data, then Bloom filter comes into play. Bloom filter is quite a powerful tool, and let's imagine for a second. So I'll take an example. Then I think that then it'll become very clear. So imagine there was a security guard. There was a security guard, and people came to him. Right? There was a security guard. People came to him, and the security guard would look up in the catalog. The security guard would look up in the catalog, and would let only the people be allowed whose name is in the catalog. So there is a security guard. There are people coming to him, and people are so the security guard is basically looking in the in the catalog and letting only those people go whose name is in the list or in the catalog. Okay. So a question from Hitendra is, any history into calling this as Bloom filter? So that I don't know, but it is quite an old technique, and it is a statistical technique for making things faster. All right. So every time somebody asks security guard, he picks up one of the catalogs, looks up the name, and lets the person in. Now this one is although the catalog is very well indexed, as in the names of people are ordered, still, since the catalog is huge, it takes time for the security guard to scan to actually look in the index for so many catalogs, or the catalog is really huge. Okay, so in the cases where this happens, when the catalog is so huge that even searching in the index is really time consuming, then then this kind of a work doesn't scale up, right? So there are lots of people coming to security guard, and as more and more people come in, this security guard is overloaded, right? The security guard is overloaded. So after a point of time, the security guard basically become slower and slower, and more people will accumulate. So there will be kind of the number of users will keep on increasing because of he is not able to give the results, and hence such a system where the catalog is humongous and the users are coming at fast pace, it would not work, right? So it'll fail. Now, so one of the technique the admin came up with, that have two security guards, one with very tiny index, and this tiny index is called Bloom. Okay, this tiny index is called Bloom. Now, the the Bloom here is a very interesting idea. Although you could actually put two security guard in parallel, some of the users going to one, some of the users going to another, but that would not speed up the process for individual user. Okay, you will be able to handle the load, but you won't be able to speed up the process per user, right? So here is a technique to speed up the process for each user. It's a very simple one. We create a very tiny index, and we put another security guard with that tiny index. Say, for example, the first two letters of everybody's name, only first two letters of everybody's name. So here we picked the name from whole of the catalog. We picked only first two letters of every name and created this index, this tiny index with first two letters. So how many such names will be there if we have just first two letters here for every name? Only first two letters, two letters. Yeah. So how many such names will be there if there are only first two letters of the name kept in this? Should I go over the problem again? Okay. Okay. Okay, here's the problem. So basically the problem is that there was an office. There's a security guard in office, and whenever a person comes to the security guard has to look up in the catalog the name of the person, right? Now there are two important things to it. One, it takes a lot of time for the security guard to go through the catalog because the index itself is huge. The index in the catalog is really, really huge. Okay. So, and the second important information is most of the people, the biggest frustration this security guard shared was that most of these people who come to me don't have their names in the catalog. Most of these are basically the 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 the, the names that are not found in the catalog, the people whose name is not listed there. So most of it is actually the bogus traffic, right? So lots of people keep on coming and they ask me to look in the catalog, and most of them don't have their names. And therefore, my task actually involves looking for people who are not there in the catalog. Okay, so 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 here he comes up with an idea that why don't we have another security guard who just does a very quick check, who does a very quick check. Let's say this security guard only maintains the first two letters of all the names that exist in catalog. So he just maintains a small tiny list of first two letters, right? Now, when somebody comes here, he checks with him that, hey, my name is there. So he quickly checks in the index with first, he just checks first two letters, right, in the index, and then says, okay, your first two letters are not found in the catalog, so you are not there definitely. But let's say for him, the first two letters are matching in his index. Therefore, what he says is, now the second security guard will perform a proper check. I do only the prelim check. Okay, so this security guard is just checking first two letters, while this security guard is checking the entire catalog. So his overhead because of false traffic, his overhead because of the bogus traffic has gone down drastically, right? Does it make sense now? So how big this index be? Anybody? If there are only first two letters. So how many numbers you can form? How many strings can be formed by 26 two letters where each letter can have 26 values, right? So it'll be 26 into 26, right? Yes. So first one can go from 26 A to Z, and second one can go from A to Z. So 26 into 26, right? Right, Noor? So had there been like 26 binary digits, 0, 1, then your answer was right. That each state is taking two values and there are 26 size. Then your answer was right. Here it's 26 square. All right. So basically it is actually not very huge. It's around 576, right? 26 into 26. 25 into 25 is 525, and I think it's 576. So this index is really small. Okay. In this example, what we have taken is a very simple way of creating index by picking up only first two letters, right? You could create a similar index by, say, just summing up all the digits, their ASCII value of all the digits, and dividing it by some number, and so on. So there are multiple ways. We just picked up first two letters. You could say that, okay, let's pick last two letters. Somebody could come up and say, hey, remove all the vowels and just just pick first three consonants, right? There could be multiple ways of creating this index, and this is called hashing. Okay, hashing means converting a string into a number, okay, by some means. That's hashing. There are multiple kinds of hashing. One is cryptographic hashing, like MD5 checksum and so on. There are other hashing techniques, such as like the hash code in Java, which is non-cryptographic, and it just converts a string into a number. All right. So there are many ways of creating this index. The idea is this needs to be kind of fixed size, and this needs to be really small, and this needs to be uniform, and so on. So this is called the Bloom filter. A question from Hitendra is 26 into 26 is maximum rows possible. Shouldn't actual number of Bloom rows be distinct values of first two characters? So yes, shouldn't actual number of Bloom? Yes, there'll be. So I'm saying that 26 into 26 is the maximum possible. That's right, Hitendra. Thank you for bringing that up. So, and they will be actually smaller than this, because there could be some of the values that are not existing in the actual. A question from Alok is, sometimes people used to call hashing as salt. Okay, so hashing as salt. So whenever we are good point, Alok. So whenever we are creating, say, hashing, we add some extra thing to it, and that's called salt. Okay, so when, let's say, I want to create password for you, right? So how does it work in real systems? So let's say I want to build a system in which I'll maintain your pass, like in case of, like in the case of CloudxLab, right? We are, say, somebody is logging in, and the user is specifying their password. So we don't want anybody to know your password. Correct? We don't want anybody to see your password. Even the sysadmin, they should not be able to see your actual password. So the way it works is always that whatever user enters as password, it is converted into one-way hash, meaning it cannot be reversed. After creating a hash, you cannot reverse it to the original. Okay, if somebody gets the access to the hash code of your password, they will never know what was your password. right? If we know what was your password, original password, then we could actually, the system admin, whosoever is there, let's say for a Gmail, they if they have access to my password, what they will do is they can actually go to, if let's say Gmail is hacked and that password is known to people, then they could actually, um, the whosoever gets access, they could try the same password in other systems, and the chances of same password being there for the same person is very high. So therefore, we keep always the encrypted version, one-way encrypted or hashed version of the password in the database, and that's a kind of a practice we follow. Okay. Now, the while we do create any such, do any kind of encryption, we add extra data to it. Okay, extra data to it, so that it further becomes harder to decrypt or guess. So that's called a salt. So a question from Alok is, what is the difference between salt and the seed? Salt and the seed have the similar behavior. Okay, so yes. So I'll explain to you with the diagram probably. These are important questions, and why I'm answering these kind of questions, because the question like this, the Bloom filter, if somebody is asking you, is going to be mostly the architecture round. If you are going for a senior software engineer position or architect position or big data architect or big data engineer position at a senior level, they would ask you about the Bloom filter, probably in the second or design round. Okay, so that's the reason why I'm focusing on that. Now, the next question was with respect to the, okay, so yeah, so generally, this is my secret password. Okay, so it is generally encrypted using a one-way hash. Okay, something really uh, random, which there is no way possible to reverse it. Reversing it is not really possible. Okay, now the other one, the other thing I wanted to say, tell you is that while this secret password, we generally put a salt in it, okay, so that this is what is encrypted together. Okay, so that it is further difficult. Also, now question is, this is what is saved in the database, right? So question is that how does the checking happen? Let's say somebody is logging in, okay? So along with authentic login, it has provided the other details. We call it, let's just call it auth details. Now again, it'll be the same encryption. Let's say here we are putting, say, SHA-1, okay? So the same SHA-1 algorithm to encrypt it would be used here. Okay, so I'll just make it look like this. Okay, so same algorithm will be used in this, and then will be checked whether these are same or not. Okay, it'll be checked whether these are they'll be compared. So this is what the user has logged in, user has provided, and then once so it'll be encrypted with the same algorithm as here, and then the result will be compared. Okay, so instead of comparing this with this and saving the secret password, we compare this and this, the SHA-1. All right. Okay, I hope that makes sense to you. Now going ahead and yeah. So could you explain the Bloom filter again? Bloom filter is basically very condensed version of your index. Like for example, for each string we create a hash code, or you can say that for each name here we are creating only first two letters we are picking from every name. So Bloom filter is having a Bloom. Bloom is nothing but first two letters of everybody's name in this example. Okay, so that this first security could just quickly say that, hey, this user is not allowed the because the name is not matching, right? So that's how it is. All right. Now let's take an example of okay. Let's take an example of probably say this class itself. Okay. So we have say Alvin and Alok, right? We have Alvin and Alok, and let's say we have Bharati and we have Pinta, right? Okay, let's say these are 4 people in the class, and this is in the register. Okay, so what we do is quickly we create the in this case okay, so this was these strings that you see here are the catalog. Okay, this is the catalog, and we're going to pick the first 2 letters of this catalog and create a bloom out of it. So this is what it is, and yeah, so you can see that here Alvin and Alok start with the same one, and we can also take another example of Ravi and Raju in this case. So it'll be RA. Okay, so let me just okay, and we can just say convert it to lowercase. Now, so this is what you can see that AL is repeating, so we can remove AL, and RA is repeating. So this is our bloom, right? And when let's say somebody comes and says, hey, my name is Alvin. So you just check the first 2 letters, and the first 2 letters basically, if they're matching, then it says, hey, you are found, just go to the next security guard. If it's not found, then it's not allowed. Now, let's say somebody comes with name, let's say, okay, Sanjeev, right? So, and the name is not here, or somebody with name called, let's say Apple comes, right? So AP is not there in the bloom, therefore he will be rejected. So basically the bloom is essentially creating a very tiny index out of used data and used as a preliminary check. Now, so you can all again, let's say this is the main storage, the main security guard, and there is a filter we have created in front of it. So first user comes, says, hey, do you have a key 1? So if the bloom for key 1 is not found, he can confidently say that, hey, not found, there is no need to go ahead, right? But if filter says yes, key 2 is found, then the actual checking will happen. Okay, so filter can confidently say no, but filter cannot confidently say yes. Okay, because for yes case, the actual checking must happen because 2 people could have the same hash code, or 2 people could have same first 2 letters, right? So there could be one such case where filter says yes, you are found, and the storage says no, you are not found. Okay, so there are basically these 3 kind of cases. Okay, so filter says no, then it's no. Filter says yes, then actual checking happens, and actual checking could say that yes, you are allowed. Similarly, if filter says yes, then actual checking will happen. All right, so this is what is filter. Now, so we talked briefly about hashing function. A hashing function converts used text into fixed size numbers. A hashing function could be as simple as sum of the ASCII values of all the characters and then modulus 100. Modulus means divided by 100, and whatever is the denominator, whatever is the left, whatever is not denominator, whatever is remainder is the answer, right? So remainder, if you divide by something by 100, the remainder will always be lesser than 100. and therefore this modulus will ensure that the outcome is always lesser than 100, and hence fixed size. The outcome is going to be a fixed size. So this value always be less than 100 no matter how big is the text and so on. So basically the sole idea behind the hashing is to make sure the hues content, hues index is converted into small list of things, and we can confidently say no in the primary check, but we for actual for actual checking, if somebody is found in the bloom, the whole actual storage lookup need to happen. Okay, so now next question that people ask generally is, does it make sense to have one more bloom filter over another bloom filter? Does it make sense to put two security guard, one more security guard in front of the second one before the preliminary? Should we have pre checking, right? The answer is no. Okay, because in case this bloom is big and you want to create another bloom because this one has grown bigger, if you want to create another, instead of doing this, you should just choose another bloom filter, choose a better bloom filter. Maybe you divide by a smaller number, and whatever is the remainder you pick up to decrease the size. Okay, the important part is the bloom has to be so small that it can fit in the memory, and we should be able to do a quick lookup, right? So we generally don't create multiple bloom filters. Now, how does it work internally? It's an important aspect. So even though it's not much related to HBase in general, but I want to cover it because it has been asked multiple times, and I've seen it being asked multiple times. Okay, and this concept is very much applicable in general the big data world, although this is not directly applicable in Hadoop, but in case of humongous data, this is definitely applicable. So imagine that. So the way this is implemented is, first of all, actual catalog is converted into numbers. Okay, not first two letters were just for the to give you an example. Okay, so every content is converted into a small number, a small integer, you can say. And then for each integer, basically we create a huge array representing the bloom. This is our bloom. And the way it is that, let's say we want to say that 5 is the value that is existing, 5 corresponding to, say, my name. Okay, so what I'll say is, in the array, we create an array with these indexes. Okay, with these indexes marked as true, remaining as false. Okay, so we have 5 marked as first mark as true, 1 or true, we can say. 6 marked as 1 or true. Similarly, 10, 11, and 15 marked as true or 1, right? So this is a bit array. Bit array is Boolean array, where we have 0 and 1s only. So we have this humongous array with the indexes of the text, right? You can think of it like a big hash table in which the key is this number. This number is nothing but converted from the number generated by hash code from the actual content. So you can see that the hues content is each name of the people is converted into this number, and this number is the index for this array. And whenever somebody is asking for something, you look up in this vector or then in this array and see if it is 1 or 0. Okay, so the moment it looks up somebody in this array and sees, okay, this is 1, it says quickly that, hey, he's allowed. So you can see that here the the lookup of bloom is extremely fast. This one is extremely fast. Why? Because computing the hash code is generally faster, really fast, as well as looking up in the memory, that too in an array, is again extremely fast. Okay, so bloom basically works as a preliminary filter for most of the queries, and it basically filters all the false positives, right? All the false data, all the data that is spam. Okay, So if let's say you have a huge table and you know that most of the people are searching for invalid keywords, and most of the time of actual search is going in searching for invalid keywords, then you can put a Bloom filter in front of it so that most of the invalid traffic, the traffic for which the data actually doesn't exist, would be dropped by Bloom filter. Okay, so this was the Bloom filter. With respect to HBase, the Bloom filter can be enabled per column family. We can enable a per column family so that when we are searching for data in that column family, then it becomes really fast. Okay, if specifically when we are searching for invalid words. So we can enable it per row, per column, per row column, and so on. So there are three different kinds of Bloom filter. One is per Okay, so we can enable or disable the Bloom filter per column family. Okay, and inside each column family, we could mention that we want the lookup to happen based on the row and column combination. So it'll create the Bloom based on either the row key or row and column keys as well as data. Okay, so Okay, so in case it's only row, then only the hash of row key will be added to the Bloom on each insert. If it is row column, the hash of the row key plus column family plus column qualifier will be added to the Bloom on each insert. And so if you want more details, you can look up there. And these are a few of the examples. All right. The other thing that we would like to discuss, the last topic in case of HBase, that basically the HBase, we have the RESTful web services. Basically HBase allows us to query the data or upload or download the data by the way of REST interface. Not only HBase, not only from the Hive, not only from the console HBase shell, but also from the HTTP call, directly from the browser. Okay, so I think I did share this, right? Is this the one? Okay, so the REST interface that you see here is okay, so RESTful web services are the best way of providing the interoperability between computer systems because REST interfaces are not programming language specific. Okay, and you can quickly call that from any kind of language or any kind of client. Even you can call it from the browser. So generally, when you are designing a RESTful interface, you will be basically creating a server, and the server should have this kind of format. So generally every server has this kind of format. There is server name. This is the server name. This is the port number. This is the user colon password. This is user info. This is scheme. There could be scheme like HTTP, HTTPS, or you could also design your own scheme if you want, but that's rarely required. Generally, we go with HTTP or HTTPS. Then path, then rest of the key value pairs, and then the fragment. Okay, so let's take a look at, so basically this is the general standard of REST interface. The other parts that are important for REST is you should use various kinds of calls, say get call or put call or delete call. So if you are calling this service, this RESTful URL by the way of get, it is generally for read-only data that you want server to give you some kind of data. Okay, you are not changing the state of server. Okay. And if you're doing put, that means you want to upload something, or if you're doing delete, then you want to delete something. So those are the various kinds of calls to any RESTful interface. All right. So here, let's say we start a RESTful interface for our HBase. Okay, we can start a RESTful interface for our HBase. Okay, so I can clear all drawings. Okay, now, so let me just start the RESTful interface here. So let's take this one. If this port is busy, you can pick up any other port. Okay, so here we're saying that, okay, it says that the port is already in use. Okay, port is already in use, so we could choose some other port, let's say 4400. This time it seems to be working. Okay, now let's say we go to, okay, let's say we open this URL. So this is the format of URL. You generally have first one is table, followed by row key, followed by column, then column qualifier, as in the column family, followed by column qualifier, and so on. Okay, and you also can specify the timestamp and so on. So you can get exactly the everything via the get call. Okay, so which server did I start? I started at E, and let's say this was the URL. Port was 4400, correct? So port was 4400, and then the some table name was this. Table name was this, and the row key was what? Here row key was, let's say row 1. Okay, let's say row 1. Column family is MyCF, right? MyCF, and let's say the data, row 1 MyCF, what else? Row 1, this is row 1 MyCF call to, okay? Call to, COL2. Okay, so when I make this call, it is going to talk to my service here. Oh, okay, has it started? Okay, so let's just keep this URL in case it's needed and try again. Okay, let's see. 404048. Okay, let me start on this one and see if this port is working, because we had enabled only certain ranges of ports. So 40, what was the port number? The port number was 4048. Okay, 404048, right? So I hope that, okay, looks like this time it seems to be connecting. Okay. Yeah. So once it connects, it gives you the data in the form of file. So you can see that the data that basically it's the browser that is doing it. If we had a proper HTTP client, this will basically be shown as the output. So you can see that it has given us a particular value. Okay. So you can make a call to your table and get the data. All right. So also there are many other use cases of the RESTful interface. Okay, such as creating a web application, making an AJAX call, and embedding data from here, and so on. So there are many use cases which are there for AJAX, because it basically opens door for all kinds of clients and all kinds of applications. So you can call it from the web application, you can call it from anywhere. Okay, if you want to take a look at this, is the link I have. All right, so we can also, if a column contains the JSON response, JSON data, it can give the JSON response. Okay, but the header will not have the JSON header, like response type will not be JSON. Okay. A question from Prashant is how to get more than one row or column. So here it says that the row, the column as in qualifier is optional. So if we put, say, a particular column family like this, okay, so it should generally give you the did I stop the service? No. Okay, not this one. I'm really sorry. I actually gave you a wrong URL. Okay, I should use 4080. Is it right? e.cloudxlab.com. Okay, so it says, all right, we can't connect to this one. Why?
Sandeep, port is 4048.
404. Oh yeah, thank you so much. All right, thank you. Is that Alok? Yeah. All right, so this time we have downloaded this file. It shows only the column 2, 4048. Let me just put 4048. Okay, so let's say, okay, so there is only one column here in this particular row. In this particular row, mycf column 2, mycf dd. So ideally, it should give us both of the data. Let me remove these and try again. Okay, so why changing every time? Okay, so if I say give me the all the rows in this column family, row 1, okay, I got it. So basically in the row 1 we have this, right? So okay, let's say I say row 2 and don't specify, okay, row 2, which is this one, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Okay, so row 1 is okay, then no, row 1 is not okay. 1 2 1 2 1 2, and then I say give me this data. So we need to specify at least a column family. So you can see that. Okay, this time it has given us only DDD. All right, mycf column 2, column 1. It should actually give us both, right? 4048 SG and mycf. Okay, so this is the latest one. Okay, for some reason it is basically giving us, okay, I see. Oh, actually the values are same in both. Okay, so can I just, okay, so is there a way to, 4048 and then I say mycf. All right. Good. So basically, we need to figure out how to just access all the columns instead of only one column. That is not happening here. So probably we might have to tweak it a bit. Okay. Or maybe we can specify them as a comma separated values. Then I think then it will happen. Okay. So here, if we say myCF colon column 1 comma myCF colon okay column 2, so okay, so okay, so here it says row followed by column, then the qualifier question mark, meaning they can be 0 or 1, but then again this format. Okay, so ideally it should work. myCF colon this. No, it is not working. Okay, never mind. So we'll look into it later. All right, let me just put it as a to-do. Okay. All right. All right. So great. A question from Grishma is that HBase thrift server cannot be contacted at this above error when I open. Yes, because that IP address that you are trying is the internal one. You will have to use E, F, or G instead of that one. Okay. Okay. So the way I'm using, do you see that? The way I was using e.cloudxlab or f.cloudxlab in the same way. Okay. So let me take a look at yours. So I've stopped sharing the screen and you can share your screen. Grisma and Noor, you can take a look. You can share your screen.
Okay, let me show you. Can you see my screen?
Okay. Okay. Yeah, there is. Okay. Could not be contacted. Just switch cluster. Say cluster 2. Yeah. Cluster 2. Okay. There's some idea in Hue to create clusters in which you could list multiple HBase servers. Yeah, I think that should have.
I think even yesterday I had same issue with Hive also. Like in that case, should we
Hmm.
also? What should we do? I mean, yesterday I could not run anything on my.
Is it?
Yeah, Query editor. It was throwing me some errors. Now it looks
Uh,
fine. I mean, if I open Query editor also last night, it
okay.
was throwing this.
Have you sent the email in reaches at CloudxLab?
No, I did not track
Okay.
any.
Probably somebody else was facing the same problem,
Okay.
so that was fixed and was resolved. Okay. So it
Okay.
wasn't basically on the server side. All
Okay.
right.
Okay. Thank you.
Okay. Yeah. All right, so yes, let me just share my screen back. Okay, a question from uh, Noor is that same error with me. So Noor, were you facing the same error as Grisma, or do you need, should I let you share the screen as well? Okay, okay. All right, so there is some, you know, the, I mean, something with the Hue that it basically has clusters and those are created by default while installing Hue, and that's where the confusion is. All right, so yeah, So coming back to it, so we have e.CloudxLab here. So a question from Sachin is, do we have steps for this exercise? The steps are basically really simple. Launch this, launch this. I mean, just change the port to maybe 4043, 4045, 40550, and so on. So we have allowed all the port starting with 40 something so that anybody can launch their service and access from outside. Also, take a notice of what is the terminal terminal, which one are you on? So I'm on e.CloudxLab, e.CloudxLab, so here, and then we have then we are providing this kind of a URL. It has the it has it has the table name, row key, as well as the column name. Okay. Also here you see I've provided the domain name followed by the port number. Okay. So I hope this is clear to everyone. So this is how you can access the REST interface. The other options, you could give it a try, changing the trying to access the other more column family and others. Okay, so similarly, if you have a proper HTTP client or you are writing the code, you can actually programmatically call the put and interact with the HBase by the way of put. Okay, all right. So you can have a look at more at this URL. This is the HBase Stargate. Stargate is nothing but the REST service, the one that we have just started. Okay, so all right, so this way, so what we learned today is that uh, the data model of HBase. Then we learned the Bloom filter, and then the REST interface. How does it work and how to access? All right. Also, if you want to have a client like JDBC, as in you want to query HBase using SQL, probably you can use a client mm, called Phoenix, which actually allows you to query using SQL. Okay. Also, you could use similar systems like you can actually connect to HBase via Hive as well by providing a different table formats. Okay, so Hive can also query HBase. So most of the HBase does not provide its own query. Instead, it lets people query by the way of MapReduce. But you can write your MapReduce to talk to HBase and process massive amount of data. But HBase does not provide any kind of SQL query. Instead, it provides a very rudimentary put and get kind of model. Okay, set and get kind of a model. All right, so this is HBase. So that's pretty much with respect to HBase. A question from Rajan is, there are a lot of similarities between Hive and HBase. Can you give example use case? Sure, let me just go over this. Good question. Okay, so let me just put these in a more concrete fashion. So Hive we use in case the data is relatively static. Okay, so actually you will notice that Hive and HBase are actually complementary. Okay, so what was Alok's question? Oh, let me just go over the W question in a minute. Okay, so while HBase you use when specifically when there are lot of writes. Okay, lot of writes. So that's basically 1 versus 1. Okay, and in case of Hive, we do have data updation as well. Okay, we do have data updation, but it is primarily used for querying humongous data. Okay, mostly used mostly used in let's say data warehousing. Okay, while in this case the answer the third one is mostly used in mostly used in uh, mostly used in mostly used in the situations where there are a lot of traffic, so mostly used in web applications, streaming, stream processing, and any other situation where a lot of data needs to be written continuously by many clients. Okay, so follows follows RDBMS sort of structure. Okay, like for example, you don't add row columns, while in this case columns can be added on the fly just like rows. Okay, so this is basically the difference between the two. Okay, all right, so okay, it does not provide any querying capability. You can use you can use so it does not provide any querying capability. You can use the what do you say? You can use MapReduce, Hive, or Spark SQL to query. Okay, so that's about the difference between the two. Okay, I'll just insert it as here, so that could be used with. Okay, so I'll just update the slides with that. Okay, looks really horrible, but it'll come in control. All right. Okay, so all right now. Okay, so still looks really horrible. Okay, now man. So all right, so now it is in control. All right, so this is basically the way we look at HBase in Hive. Okay. A question from Alok is, but we can query though through Java client. That's right. Querying here out of the box, it basically provides get and put kind of querying capability. Okay, get and put kind of querying capability. So yes. All right. All right. So this PDF is updated now. You can access the PDF as well. Good. Now moving ahead, great set of questions. Yes, we have sufficient time, don't worry. Okay, so we are going to start with Sqoop. So that was pretty much with HBase. I think we can now start with Sqoop and Flume. Okay, so all right, so now we are ready to do that. Okay, a question from, are you going to give us example of Spark SQL to query for HBase? Sure, we can do that. Okay, let me just put as my to-do list. Okay, we have not had it before, but we'll just put it in the to-do list. Okay, also probably an example on Hive would be better. So let me just prepare that. And once we are doing that, I'll just send you an email saying that, hey, we have created a small tutorial on how to query HBase using Hive so that you can try. Okay. A question from Alok was, yeah, yeah. So let me just talk about that. A question from Alok was with respect to Tableau. So yes, so Tableau is basically a way to visualize data, right? Let us say you have data in certain database format, tables, and you want to query that data. And whatever the query results are, you want to present it in a nice format like a chart, pie chart, or something else. So when you do that, you should be able to see you should be able to present the data in various very user-friendly ways, right? Those are the reasons why people use BI tools. Okay, there are many BI tools. BI means business intelligence tools. There are many BI tools. One is open source called BIRT. Okay, you should take a look at BIRT. The oldest one was Crystal Reports. Similarly, there are many projects around the world, and on the same lines, we have Tableau. Okay, Tableau basically connects to any data source like a normal database or a file system or S3 or any other thing. So basically, using Tableau, you can present your data. So somebody has unmuted. Was it intentional? Yeah. So I think somebody has it. Okay. So a question from Hitendra is, can Tableau query HBase? I think it should be possible. Okay. Now, so basically using Tableau, you can mostly query most of the systems. And using Tableau, you can query Hive as well. So in the video that is provided to you with the in the project, the Hive project, you can take a look at the video and you will get the idea about how to query using using Tableau the Hive tables. Okay, the one that we discussed earlier. Is that your question, Alok? Was able to answer? Okay, so cool. So let's take a break for 10 minutes and we will be back by 9:51 IST. Let's start with Sqoop. Sqoop is basically just give me a second. Okay. Okay, just give me a second. All right, no worries. So Sqoop is essentially an open source tool to efficiently transfer bulk data between Hadoop and structured data sources such as MySQL, Oracle, or HBase. Okay, so using Sqoop, let's say you are starting the big data environment in your organization and you have a lot of data in lying in RDBMS. Say you have a lot of data in Oracle or any other database, and you would like to transfer that data to Hadoop platform, whether you want to transfer to HBase, you want to transfer to um, file system like HDFS or Hive. Okay, so on one hand, you have these tools such as RDBMS, Oracle, MySQL, Postgres. On the other hand, you have HDFS, Hive, HBase. So these are the kind of so when we say import or export, this is which side we are. Import means from this side to this side. Export means from this side to this side. All right. So so basically, using Sqoop, you can do both import and export. You can connect to all, in very simple word, you can connect to almost every database that supports Java connectivity, and almost every database on the planet as of today provide JDBC connectivity. Now, so the basic command is Sqoop. From the console, you can just execute Sqoop. You can go to console here. Okay, so you could go to this place and all right. I'll just share the link with all of you. So this is Sqoop, and I'll just also share the Flume. This is Flume. All right, so I've shared Sqoop and Flume both. Okay, so we have the basic command is Sqoop. If you launch Sqoop command here by saying help, you'll be able to see all kinds of commands. All right, so let's say we have code generation. We'll talk about code generation later. We have create Hive table, export, import, and so on, right? These are the various main commands. If you want to understand, let's say about export, you could say Sqoop help export, okay? So it tells you all the details about export. So you can, how to connect, what are the settings you need to provide, and so on. Okay, so basically, using export command, you can export an HDFS directory to database table, and so on. So these are the various commands. So let's start with a simple objective called importing from MySQL to HDFS. Let's say we have a table called widgets in MySQL. Okay, we have a table called, say, um, widgets in MySQL. So you could simply use Sqoop import and then import the table. Okay, and so I'll just show you. Okay, let me open multiple terminals because multiple terminals will be required. Okay, so the MySQL credentials are here. Okay, these are the credentials for MySQL. So you can actually log into MySQL parallelly and take a look. Okay, and right. So okay, let me just see if we could. Okay, so I'll just show you. All right, so let me log in into MySQL and show you the data that we are trying to import. So first terminal, the first terminal we're going to keep our for. Okay, so let me just open one more terminal here. Okay, so we have two terminals here, one here and other. Okay, so here let's just connect to MySQL, and the username is, okay, first hostname. Hostname is, okay, so MySQL hostname is this, username is Sqoop user, and password is something that we will enter later. Okay, so password is different. Please note that it's not same as your normal login. All right, so here you can see that we are logged in into MySQL. We logged in into MySQL, and there we will take a look at the database that we are trying to import. First of all, here using this command, we are going to talk to ScoopX. ScoopX is the database, so we'll say use ScoopX, and here if you take a look at show tables, okay, there are quite a few tables. Out of this, we are going to import this widgets table. Okay. All right, so you can see that this is the data inside widgets table. All right, so if we use this table here on this side, okay, you use this command called scoop import, connect to this database, the one that we are just connected to, and then say, take this particular table, use two mappers. Okay, we'll talk about what does it mean by two mappers. And then we are saying split by ID. Does ID column exist? Yes, it does. Okay. Now going ahead with this, going ahead with, okay, so here on the console, we are saying scoop import, connect to this particular port and execute. Okay, it is asking for password, so we will just copy paste the same password, the MySQL credentials. So what does it say? It says that the output folder already exists. So we can delete that output folder. So again, what is it that we are trying to do? We are trying to copy a particular table into HDFS. The in table exists in MySQL database, the cloud standard databases, and we are trying to pull that data into into the HDFS. Okay, what does it say? It says access denied for this particular user. Let me try again. I think I pasted wrong password. Okay, please notice that it is using, we are copying the data from MySQL, which is this, from to our HDFS. Okay, please notice that it is using the MapReduce command. So you can think of Sqoop as a specialized MapReduce job, which runs for importing data. Also notice that it has only the mappers, right? It has only the mappers because there is no group by, there is no aggregation that's happening, and there's no aggregation that's happening, and so on, right? That's why there is no reduce phase. It's only the what do you say? It's only the mapper phase. Now here, if you go to Hive, you can see the table that we have just imported. If you go to file browser and here you see widgets, you see zero part, Okay, so you can see that some of the records are in first part, right? From this table, the one that we're talking about, this table. Some of the records are in first part, and some of the records are in second part. Okay, a question from Vinta is, this does not work for me when I say MySQL H this. Okay, let me just take a look at your command. Okay, so this is here. Okay, so just don't specify password. Try without the password. Let it prompt for the password and then copy paste the password. Okay. Okay, I think that's the only mistake I see. Other than that, everything looks perfect. All right. And once you log in, then you say, after that, you say, use Sqoop, use Sqoop, and then you say show tables, all right? And then you say select star from widgets, just to take a look at MySQL side. So in the first terminal, this is what we are doing, right? And in the second terminal, what we have done is we have just executed this particular command. Okay, this is in the second terminal. All right. Now, parallelly, we have opened the HDFS file system to take a look at the imported data that we have just did. Right. So, so for the table in MySQL, it created a folder in HDFS. It created a folder here in HDFS. Okay. And in the folder, it has put these two parts, part 0 and part 1. All right. Done, everyone. Okay. All right. A question is, what is it that P is split by ID? We'll come to that soon after that. Also notice that in the folder where we were executing, it has created some Java code. Okay. You can see there is a file called widgets.java. Okay. If you take a look at that, you will notice, you will see here. So you can see it's some kind of a Java code, right? What is the need for such kind of thing? If let's say you want to automate this process of importing data from MySQL to HDFS and you want to customize the process, then you can you can take this Java code and update this Java code according to your choice. Okay. A question from Grishma is, where is the link for Sqoop slide? I have shared in the chat. Can somebody share it back? Okay. And all of these slides are also available as part of resources in the self-paced course, which is provided to you parallel to the current course. All right. So great, great. So basically what's happening in the background is it's a MapReduce job that's running. There's a mapper 1 on machine 1, mapper 2 on machine 2, and mapper 3 on machine third machine. So this is what happens, right? So basically what happens is, okay, All right. So yes, I think I have shared the command, so you can actually use that one. That there is a break in the command, so you can correct that command. I'll just correct the command. Okay. I see. Now it's better, right? So yes. Okay. So in the background, when we are executing this job, you must have noticed that before this, you must have noticed that it was basically a MapReduce job. There were total two tasks that were executed. We could, and essentially what it did was it distributed the work to multiple machines. There are two mapper, three, let's say we were using the mapper S3 dash M3, it would have created three parallel mappers. So there are three parallel machines which are connecting to the same database, same MySQL, and bringing the data from there and putting parallelly the files into the same folder in HDFS. So one task created first part, second task created second part. Okay. This way, the entire process of reading the data from MySQL becomes parallel and is more efficient, right? Because writing takes more time. So writing became parallelized while reading can be done from one machine. Writing is done on multiple machines and reading is done from single machine. So reading is generally 20 times faster than writing. Therefore, it's okay. It basically makes the entire process around 20 times faster by using the MapReduce for copying data from MySQL to Hadoop. Okay. All right. So, Binta, you could use the command that I shared with you, the one I shared, because the previous command that I shared, it had a break. It has a new line in it. That's why it became into two line. All right. So just now, the one that I shared just now, this one should work. Okay. So all right. So is everybody able to execute this? Yeah. All you need to do is go to the console, web console, or any console, and execute this command. A question from Alok is it possible to do vice versa from HDFS to MySQL? Yes, that's called export. Question from Sachin is, what the role of MapReduce? Here, it's only the mapper, not the reducer, because when you are reading humongous data, let's say petabytes of data, right, or terabytes of data, you would like to make the process of writing to Hadoop parallel. So instead of one machine talking to MySQL, multiple machines will talk to MySQL and bring data to your Hadoop cluster. Okay, that is the role of mappers. Make sense? So role of mappers is to basically make it such that multiple machines bring data from MySQL into the Hadoop ecosystem, into HDFS or Hive. Right. So internally, Sqoop is launching the MapReduce job for us. Okay. Internally, Sqoop is basically launching these multiple mappers for us. A question from Noor is, where does it copy the files? It basically moved the files to HDFS. Okay. If you go to here, it has copied in your home directory. Okay. So Binta is facing this problem. Okay, you could share your screen. I can take a look. All right, Sachin. So the basically Sqoop is launching the mapper jobs. This one is not a MySQL command. You are is still in the MySQL prompt. Okay, so you will have to exit from MySQL. Okay, this needs to be executed in the console. It's a Unix command. No worries. Yeah, that's correct. All right. So you can copy password, copy paste the SQL password. Yes. What does it say? No columns to generate for classifier. Okay. Ah, that's right. Maybe it is that. Okay, just paste it. Okay. Yes, it is working finally. Now you can take a look at HDFS and you will be able to see this widgets folder. Okay. You could say widgets slash asterisk. Not complete slash, just say widgets without slash. Yeah, widgets. WIDG. That. Okay. All right. Remove that VJS, right? Widgets as in WIDGET. Okay. Just take a look at the folder that has been copied. You'll get an answer. Okay. All right. So, okay. Basically, that folder is the spelling of folder is W. Okay. I'll just share that folder link with you. And all right. So here you go. Okay, I'm just sharing with you. All right. WIDGETS and slash part. I think rest you can figure out. Great, great. I think you're done. All right. So you can do it at your own convenience. That should be good. Wonderful. And a question, Robin, you can go ahead with sharing. Okay. A question from Grishma is, we cannot do CD to widgets because widgets is in HDFS, so the CD would not make much of a difference. Okay. All right. Just remove semicolon. It should work. Remove semicolon. It should work. Okay. It says Sqoop connect JDBC this table widgets. Sqoop user this. Oh, there is a space between split by and double dashes. Go up one. Yeah. Just remove the space between double dash and split. Yes. Okay, so it say split by ID. Okay, did we make a mistake there? Split by ID. Table is widgets, and there is a widgets table. Okay, username is okay. What does it say? It says that unrecognized argument called P. Okay, is it capital P or small p? I think it's capital P. No, you'll have to paste the password. Okay. This copy paste doesn't work, that copy button. Good, good. Now you can take a look at the widgets table in Hue and you will get the idea. All right, wonderful. Great, great. Now, okay, observation from Noor. I changed -am3, it created 3 files. Great, great. That means there were 3 mappers. A question from Sachin is, so if we install Sqoop, then mapper comes by default. Actually, the Sqoop comes with Hadoop, okay, and Sqoop would depend upon Hadoop to be installed, okay. So basically, whenever the way we were launching Hadoop Hadoop, what was that? Hadoop MapReduce jobs, Hadoop jar. In the same way, the Sqoop is also talking to the Hadoop um, MapReduce jobs. Just like Hive was executing MapReduce job underneath, Sqoop is also executing the MapReduce job. Just that in this MapReduce job, there is no reduce phase. No reduce phase because all it is doing is reading data and putting it in HDFS. There's no aggregation, group by, sorting, anything. Any of the shuffling phase is not there. All right, did it make sense, Sachin? So Sqoop basically is a small program which internally calls Hadoop MapReduce. It expects you that you have already installed Hadoop because it generally comes as part of the Hadoop. All right, wonderful. So we all are successfully able to do hands-on with this Sqoop. In the same way, I think you should all try other hands-on. Okay, the next command basically copies the data from MySQL to HBase. So here we have Sqoop import from this URL, this table, same table, into a HBase table. Okay, so here we need to specify, because when we create an HBase table, there are a few things that are mandatory. First one is HBase table must have a column family, correct? Therefore, we need to define a column family, right? So while importing the data from MySQL, it says that which column family should these column be added to. So we need to define that column family. And then we need to, this is standard, then we need to say HBase create table, followed by which all columns do you want to be copied. So the data from these columns will be copied into this column family. Okay, if let's say what you want is some of the columns go to one column family, some of the columns go to another column family, you basically do one column family at a time. Therefore, you will have to execute this command twice. Once for first column family and second times for another column family. So basically you execute this Sqoop import command twice, once for each column family. And then we say the row key, the second part, first constraint with respect to HBase table is the column family. Second constraint is the row key. We must have a row key, right? So we say that, okay, the row key is going to be this. All right, row key is going to be this. Let's see if it works or not. All right, let me just check from the SQL console if it is working or not, because there is uh, no column called there is no column called row key. Ideally, it should have been the ID. Okay, so it says that uh, correct column name, please. Okay, so it seems that you're looking up for the column that does not exist, right? So we'll have to change that part. So we had ID, widget, and so on, but we don't have those names here. So we'll just put ID and name. That's all. ID and name. Correct? All right. And let's say we want to create the row key based on the column called name. Okay. So there and yeah. All right. So we have basically, all right, we have imported the widgets table, and then we can take a look at the table using HBase, right? We could just say WID widgets. All right, I'll share the command with you. You can change the name of the widgets table. We have uploaded to HBase. Sorry, if I said Hive, we have uploaded it to HBase. And let's take a look at widgets here. All right, so you can see that there is a table called widgets, and here we have, okay, somebody has, okay, so column family 2, somebody has done this badly. Okay, so why did the last, okay, row key is this, ID and last name has gone into this. Okay, so did I mention the last name somewhere? Okay, I'll just change the name to something more specific so that we don't override, because what happens is if you run import multiple times, basically the imports, if there is an insert, it basically updates if the same key, same column and same row is involved. Okay, so I'm saying SG widgets, and let me just copy paste the password of SQL, and that's pretty much. Okay, so we have here, let me just go back to where we were doing. Okay, so all right, a question from Sachin is, what do you mean by column family? As discussed in the case of HBase, right? A column family is group of columns. It is the HBase terminology that we had discussed in the last session. Okay, all right. So here it has basically added these columns into, no, not this one. All right. Yeah, you can see that. Now we have said that import these columns, right? Import these columns, right? And in this import, right, we were using only two columns, ID and name. Out of this, name was essentially the row key, okay, and ID is the column. Okay, so ID is the column and the row key is the name. All right, so that's why we have this kind of a table. And we have said here that create a column family, CF2. So the column family here is CF2, correct? So that's how you import data in bulk into HBase from MySQL. Okay, you can do the same thing using any other database as well. You can import from HBase, you can import from Oracle, MySQL, Postgres, or anything using the same format. The difference will be in this. Here you will have to say use the different URL. You will have to say JDBC colon the name like Oracle or Postgres, and then the IP address of that one and the database name. Okay, so that's how you will be calling. This is called the SQL connection URL. So you will have to use a different URL. That's all. All right. Question from Grishma is, can you explain the HBase table again? Sure, sure. So what we did was we changed it a bit. Okay, so going back to our command, the command that we just used. Okay, the command that we just used was this command, right? So here we were importing which all columns? We were saying ID and name, two columns, correct? Out of which we said the row key is going to be name. Right? So column is only actually one. Now, next one is we are saying column family as CF2. This is the column family. So these, whatever data we are going to import, it is going to go to CF2. All right. Now let's go back to the diagram here. So here you can see that the row key is Anna, Ben, Chris, and so on. These are the names from the data. This is the data that we are importing, right? These are the names. So since row key is this particular column name, that's why the row keys are these, right? Then inside it, we have column family followed by ID. So then you can see that every row has column family and the column. All right. And there was a way to represent it like a grid, like this. Okay, so this is all right. Good, good. So I think this is now clear to all. This is now clear to all, and I'm just seeing if we can present it in some other way. All right, wonderful set of questions. Great. In the similar way, we can import the Hive tables. Okay, so we can, let's say we have created a Hive table like this, we loaded the data, then we can simply, okay, sorry. So we can import the data into Hive as well from the MySQL in this way. We can simply say scoop import from this table and this particular table into Hive. So it'll basically create the table in Hive and load and copy the data to HDFS and load it in Hive. So it'll do all the three steps in a single shot. Now, if you want to do reverse, let's say you want to go from Hive to MySQL, you can also do the same thing. Let's say we created a Hive table, then loaded the data, then we can, and at the same time, we will have to manually create MySQL table. Sqoop is not able to create the MySQL table, so we'll have to create it manually and then export the data. Okay, so this is what basically happens, right? So basically, we are able to do all of these using Sqoop. All right. So I would say that all of these hands-on you must try at your own. And in case you get stuck, just reach out to me because this exercise is all about hands-on, though The though exercise looks pretty simple, right? From MySQL, we are copying data to HBase, HDFS, and Hive, and way back. So and back. So you should try all the 6 steps, all the 6 kind of import, so that you become comfortable. If you get stuck at any point, just reach out to me. All right. So we have done HBase and HDFS in the session. You could try Hive as well as exporting back. All right, so this was a quick introduction of Sqoop. Now we're going to talk about Flume. Should we start with Flume, everyone? Okay. A question from Robin is that, okay. Okay, so before I move forward, I'll just answer these questions with respect to the Sqoop. Okay, I have closed the tab. Okay, so Robin's question is that he missed some of the parts of Sqoop. Is that your question? Okay, sure. Please share the screen. Okay, let me take a look at. You are again doing the same thing. So yeah, this is the confusion. So you can exit the MySQL prompt and do it. Okay, that's why you should open generally 2 parallel prompt and then do the SQL import. Okay, the Control D, yeah, that's right. I think rest of the thing should be good. It's not there. You'll have to copy paste. All right, I think you'll be able to do it. Done. Okay, so try it now. Just copy paste and try it running. If you get stuck, just let me know. All right, everything looks good to me. Great, great, and wonderful. So yeah. All right, so the another important topic that we are going to talk about is Flume. All right, so Flume is a very, very important tool, and it is used in many cases. Okay, so the classic definition is this. I know that it's not going to make sense to you right away, but when we go through the entire cycle, it'll make sense. So Flume is a distributed, reliable, and available system. Distributed, reliable, available. All the 3 keywords are common in all the tools that we have studied so far. It's a system for efficiently collecting and aggregating and moving large data. So it's basically to move large amount of data from one place to another. And all it does is it is basically used for single destination. Okay. All right. So yes, actually, Abhinta, I had shared above. You could take a look at that, and it should be somewhere up. Okay, if somebody could share the link, it'll be great. Yeah, I found it. Okay, good. So the Flume is essentially for gathering large amount of data from all around into HDFS. So generally in an organization, you have this concept called data lake. Data lake is nothing but a place where you gather the data from the entire organization, right? We call it the data lake. Data lake is generally implemented using Hadoop file system, which is HDFS. So generally, so most of the time, what the tendency in the organization is to gather data at the central place and specifically in HDFS, and that's where the Flume comes into play. So Flume is basically quite an interesting topic. That imagine that you have web server, and this we did quite often. In case of Amazon, we had many web servers, and all of them were continuously running. So there were many web servers running continuously, and they were generating data or logs. So what we wanted was we wanted all of the logs to be at a central place within say couple of minutes, and we would monitor the logs. We will keep on. There will be a script which will keep on checking if a particular error is occurring most often. So if let's say there's an error occurring in the server side, like more than 100 times, that means there is something wrong in the server. So it instantaneously sends email to the team which is overlooking the server that, hey, there are so many errors of this kind, can you take a look? So if there is a particular error that is repeating more than 100 times, it will basically cut a ticket, as in log a request to the support team. And whosoever is on call duty that time, they will take a look at it. So that was basically a very standard use case at Amazon. And since we dealt with the website, we always got these tickets. Okay. So the way was to implement a central storage so that all the web servers will continuously push the data to a central place. And at the central place, we would run the analytics continuously on the incoming data. And we will basically keep on analyzing that if there is some kind of attack or some kind of denial of services, and or there's some kind of error that's occurring too frequently and so on. So basically, this is exactly the use case of Flume. Flume continuously, as opposed to the batch, Flume runs continuously and pushes data continuously from all kinds of sources to a central source, right? Now, a question from Robin is, can the central data store be an ordinary storage, and so on? So Flume is designed for HDFS, but given its architecture, it should be possible to store data in any kind of central storage, not only HDFS. Okay, so Flume is a generic system which can be created, which can be used with any kind of storages. And how does it do that? By the way of its architecture. So Flume is made up of agents. So you install agents on every machine that wants to push data. Okay, like you have 20 web servers, so you will install 20 Flume agents. Now these Flume agents have this kind of architecture. You have three components configured. One is source, channel, and sink. All these three are basically pieces of software connected by the way of XML, saying that, okay, this is the source, this is the channel, this is the sink. All right, so the source component, the software that is source, reads data from the user, puts it in the channel, and from the channel, sink reads. Now, channel could be either in memory, channel could be in the disk, channel could be uh, a combination of disk and the memory. Okay, so you can configure all these three kind of channels. So Flume is made up of many agents. Many agents you put in all kinds of servers, and these Flume agents absorb data by the way of source. Source basically sucks the data from the machine, from the various different sources, and channel is for basically keeping the intermediate data. It's like conveyor belt. Okay, and then there is sink. Sink basically consumes data. Okay, so by configuring correct source and sink, you can actually create all kinds of permutations. Just like you have a USB cable, source could be either this kind of USB, or if you have a different source, it could be say what do you say, the firewire, or it could be the USB-C, and so on. Similarly, on this side, it could be micro USB, mini USB, or anything. So you can change this. Similarly, the channel is the wire. You could configure it to be copper wire. You could configure it to double wire or a flat wire or whatever. So that's the ability of Flume. So if we had a very custom, if we had a custom architecture of these USB cables or charging cables, the life could have been far more easier, right? So we could just change the source and sink kind of connectors and we would have the perfect wires, right? So instead of designing the Flume agent, something which is a singular architecture, it was easier to basically have source and sink different one. So if you have three kinds of sources, three kinds of sinks, then you can actually create 3 into 3, 9 kinds of agents. All right, so this is basically what the agent looks like. The role of the agent is to take the data from somewhere and put it to somewhere. That's all. Okay, so yes, a question is where is the XML specified? We will talk about it soon. So question is, so Flume pushes data as per the schedule time or as per the changes happening, as per the changes happening. Good questions. Very good questions. Question from Robin is, does Flume agent act like a log forwarder? Can it forward syslog? Perfect. Very good questions. Yes, it can. It is basically for exactly that purpose. Okay. So how does it push the logs to remote data store? Via the IP address. That's right. Okay, good, great. And so this is what we are talking about. So if you have many web servers, you install Flume agent on all the servers, and then in the middle you put another Flume agent which is listening to both of them and then pushing to HDFS. So you can connect one agent with another agent with another agent, and you can create a network of such agents. Okay, by tweaking the sink and just by tweaking the sources, you can actually create the full grid of agents. That way, even if let's say this part is not working, at least this part will work. So you can create this resilient architecture in an organization so that the data can flow seamlessly. Okay. A question from Robin is, can it push by schedule? It is not designed for scheduled. It is designed for continuous. Where can we download the Flume agent? It is free. It comes with even Hadoop ecosystem. So you can just install it anywhere. Okay. So it supports a variety of data sources. Various kinds of plugins are available, or you can say modules are available. Sources like tail, syslog, log4j, and the reliability, it is up to you how you create your structure. You can design something like best effort, doesn't tolerate any node failures, like linear one, the one that I just showed you. This is best one, and then the other one could be end-to-end, which guarantees delivery even if node fails, right? So let's try to do this. Let's try to read data at a port and push it to HDFS. Okay, let's do that, and most of the doubts will become clear. All right, so yes. So a question from Grishma is it if it finds new logs, it pushes? Yes, that's right, and it runs always. Okay, so question is, can we install this agent on Windows Server also and on IoT devices? It should be possible because it's kind of independent, and you can basically add all kinds of Java code to it. So it should be possible to install on all kind of devices. I'm not sure about IoT devices because IoT devices generally don't have JVM. Flume is written in Java and it needs JVM to run. Okay, so wherever there is a JVM, it can run. Great. So what we are going to do is we are going to read the data at a port and push it to HDFS. So what we are going to do is we're going to get this configuration folder from somewhere. Okay. All right. So I have created this. Okay, I've created this HDFS folder somewhere where it keeps the. Let me just go to file browser. Okay, I'm going to need these two terminals, one for agent and sorry, one for creating data and other for running the agent. Okay, so all right, so here there is a Flume folder, you see that, and in this we have flume.properties. Okay, so it has here the flume.properties is what it defines. So when I said XML, this is what I meant. It's not really XML, it's basically key value pairs. So here we are defining the behavior of all the agents. Right now we have only one agent called A1. If we have more agents, we will just put more of A1, A2, A3, A4, and so on, right? So all of the agents share the same file, just that while launching the agent, we'll tell the agent that, hey, your name is A1, so pick only the configuration part which belongs to you. So here we are saying that there is an agent A1 whose sources are R1, sink is this, and channel is this. Further, we are defining that what does it mean by R1? R1, R1 means that R1 will listen on network, and the host name it will listen at this, and port it will listen at this. So it's basically going to listen at this port for receiving data. So this is the source. It's going to listen at this port. Okay. Then we are saying that this is the sink. Sink is going to write to HDFS at this location. Then third one is the channel. Channel is memory. We are not defining anything with channel. Channel has these properties, how many records can be kept, how many transaction capacity it has, and so on. Then further, first we told agent that these are your three parts. Then we configured these three parts, the source, sink, and channel. Then we told the channel that, hey, uh, we told A1's channel as that hey, your channel is C1. Okay, sorry. We told the R1, which is R1 is sources, because we need to connect the source to the channel, because source is also going to write to the channel. So we're telling the source that, hey, your channel is C1. And we are telling the channel that, hey, your sink is C1. Okay. Sorry, we are telling the sink that your channel is C1. So because sink is going to read from channel and source is going to write to channel, so we informed source about the channel as well as sync about the channel. So total number of, you can say that total number of connections we made are this and this. All right. So this is what it is. So you can just copy this conf folder to local. Okay. I'll just copy this folder for you. Sorry, you copy a folder. You can say Hadoop fs copy to local. Copy to local, data, and Flume, and we'll copy it to local. So here we have Flume folder. Okay. So in the Flume folder, I have conf. Okay. All right, so we have the configuration file. You can change these files. You can change this file. I'll just open Jupyter, and you can edit this file that we have just downloaded. So you could just Okay, so where is the Flume folder? Do you see Flume folder anywhere? Yeah, here it is. So, okay, so inside the conf file, you will see this, and you can actually edit this file, or you can select and edit. You can select and click on edit. That'll be easy. So this is the data that we have here. You can change this location to yours. You update the username to yours. Okay, so this is the Flume. Now, all right, once you're done with this, okay, so this is your Flume properties. So first thing is you copy the Flume folder to your home drive. Then second is open in Jupyter, okay, and and edit flume/conf/flume.properties. Okay, I'm not sure what is this. This is something, another example. Yeah, in case you don't want to put it in the HDFS. So this is, don't use the second one. The first one is good enough. Okay, so here we are saying that read from here and do that. All right, so these two steps are done. Downloaded this folder from HDFS and added it to make your changes. Here also notice that you should have your own port. I'm using this port, you should use some other port, and put it on the chat so that others don't run on the same port. So I am on e.cloudxlab and my port is this. So on E, we cannot have more than 2 persons doing on the same port. Okay, now the next is let's launch this. Let's launch this. Let's launch the agent here. Okay, so good. And let me open the console, and inside the Flume folder, I'm saying Flume agent ng. Okay, inside the Flume folder, so all I did was I went to cd Flume and then did this. Okay, so here let me just explain the command again. All right, I will actually keep it here. It'll be more clear. So this will be easier, right? So that all of you can refer to this one. So this is the first step. This is the second step in which we are editing the Flume properties. So here, change the port and your username. Okay, so third step is go to cd Flume and then launch this. Okay, so here, once it is done, okay, once go to console, go to cd Flume and then launch this. Okay, so once this is done, what you need to do is you need to generate data. Now, our Flume agent is happily running, listening on the port that we have specified, and is trying to write to HDFS. Okay, since there is no data, it is not going to write anything to HDFS. All right, so open another terminal. Okay, I'll just put here, open a terminal, and execute. All right, now fourth step is open another terminal, okay, and where is the terminal? This is my terminal. This is working good. Now in this terminal, what we need to do is we need to connect to this port. What was my port? My port was 4 times 4 and followed by a 0. So I'll change this to this. Okay, so right now I'm connected to my okay my application, and whenever I'm writing something, this is my first line. I'm just writing some data, and so it has gone to Flume, which is running parallelly. It is going there, and then it is basically pushing it into HDFS. Let me go to my home drive. Okay, Now, fifth step is go to HDFS home, check for the folder. Okay, so what was the folder that we were writing to? We were writing to this folder, Flume Web Data. Where is Flume Web Data? Here. Okay, so this is where it is creating the content. So creating the data. So this is the second line. Okay, second line, third line. Okay, so it will continuously keep on writing to this one, right? So you can see here that it is writing to this one. All right. So is there a way to refresh it? There was a link, right, to refresh it. All right. So we could just refresh at the top. All right. So you can see that the data is being created here. Okay. So continuously, this is, you can see, this is my first line. It's a binary data, and this is my first line. All right. So, and this is my second line, you see. Okay, so D, 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 and so on. This is the second line. All right, so it's a binary data in the format of the sequence file, so which you can read. Okay, so here you go. These are my 5 steps. All right, and you can try that. Okay, so this is what it is. Yes? All right, so this was the example of Flume. Okay, now I've stopped the Flume agent by pressing Control C. Here also I'm pressing Control C. Control C kills any process that's running, and Control D, if something is expecting an input from you, if you press Control D, that means it's an end of input and it exits. For example, an interactive shell would exit if you press Control C, Control D. All right. A question from Ethan, you talked about XML somewhere with the XML specification. So yeah, that's a good question. So basically it's a flume.properties. It doesn't have XML. This is what I was referring to when I talked about XML. I thought that for a moment that it was XML. It is not. It is basically key value pairs. Okay. How to edit Flume property files in which? So the folder that you copied to your local, right? In the first step, you copied to local, right? This folder came to you. In your home drive in Jupyter, you will notice that there is a Flume folder. Inside conf, you can select flume.properties and click on edit. Okay. So this was quick example of Flume. And in this way, by tweaking flume.properties, putting more files in the config directory, we can actually get anything done via Flume. Question from Hiten, is Kafka next generation to Flume? Actually, Kafka is a generic system, but Flume plays its own role. Kafka is for generic enterprise bus, but Flume is for pushing data from all around to a central place. Okay. Even if you add it in the console, you can do that, or you can just go to Jupyter and edit it. That's also good enough. Okay. A question from Kafka versus Flume. Kafka is a generic enterprise bus in which there are writers and readers. Okay. While in case of Flume, it is a unidirectional flow of data, that too from many sources to a central location. So Flume basically exists parallelly, and Flume can also write to Kafka, okay, and can read from Kafka. So Flume has got a specific purpose as part of the ecosystem. A question from Robin is, can Flume agent be configured to collect data from a specific event log folder? Yes. Okay, so you can actually configure it to read data from all kinds of sources. Take a look at their sources. So Flume sources. Okay, so Flume says sources. There are many Flume sources, and there are really humongous number of sources you could take a look at. Okay, so where is the Flume sources? Yes, and there are all kinds of sources that you see here. Okay, so you take a look at that. All right, so this will help you. A question from Alok is, it's kind of a river? Yes, it's kind of a river. It uh, goes, basically all the rivers from a country goes to the sea from one place to another. Okay, so it's kind of a river. Question from Ethan, Kafka is generic. Can it be used outside Hadoop? Yes. Kafka is basically non-Hadoop component, and we will actually go into more details with Kafka. We will do the stream processing from Kafka. All right, so that was quick overview of Kafka, Flume. And another question that I wanted to address was with respect to the quiz, with respect to the project. So there's pretty much with respect to the Hadoop ecosystem. Let me just walk you through what all you need to do. Okay, except for say Java, except for Java and say MapReduce programming, everything else you should perform. You should and this big. So these three parts: 5, 10, and 11. Okay, so these are optional. For rest of the things, you should complete them in 100%, and then basically, right. So up to here, you should be completing up to here. Okay, up to here, you should be completing. All right. So yeah, so up to here, up to HBase, you should complete. And there is a Hive project. This is must to do. You must follow the instructions and finish it. Okay, just follow the instructions as given here. And once you are done, just send us an email that you are done with it. And in case you want the separate certificate for the Hadoop course, we can release the separate certificate once we receive the submission for this Hive project. Okay, while you're submitting for Hive project, make sure that all of these are 100%, right? All of these are 100% except for this, this, and this. Okay, all of these are 100%, and uh, okay, that means I'm not eligible for the certificate yet. So yes, so please finish all of these along with the Hive project, and in case you want a separate certificate, please. All right. So that's pretty much. I look forward to see you tomorrow at the same time.